Hello everyone, I'm Maniratna Krishna. Welcome to this presentation on the link layer, one of the most essential topics in computer network. In this video, we'll understand what the link layer does, how it detects and corrects errors, manages multiple users, and how it's used in real life applications like Ethernet, Wi-Fi, and cable internet. Let's move on to the motivation. So why do we study something? So we're gonna study the link layer. Okay. So let's start with a simple thought. When you send a message online, your data travels through cables, routers, and wireless signals. But how do we make sure that your message arrives correctly at its destination? That's what the job of the link layer is. It ensures error-free delivery between two directly connected devices like your laptop and your Wi-Fi router. Without a link layer, even a small error in a single bit could completely change the message being sent. So this is basically how the study in link layer works. Okay. So let's move on to the next one. So here we'll study how the what's the role of the link layer. So the link layer is the second layer of the OSI model, sitting between the physical layer and the network layer. So this is the layer OSI model, and it's the layer 2, which is the data link layer, stands between the physical layer and the network layer. So what does the link layer do is, uh, its main job is to take the raw data bits from the physical layer and organize them into frames, which are small, manageable, and these are like tiny bits of units of data. It also performs error detection, flow control, and medium access control, ensuring that the data can be sent smoothly and safely over the channel. Here you can see the features of the the link layer. So let's move on to the next one. Yeah, so here we will be studying about the error detection and the correction. Like how does the link layer perform these two things? So data transmission is rarely perfect. It can never be 100%. So there are many reasons like electrical noise, interference, or weak signals which can flip bits during transmissions. To handle this, the link layer uses error detection and correction techniques. The simplest one is the parity check or the parity bit. So what it do is, where an extra bit is added to make the number of ones either even or odd. So then there's checksum, where the sender adds all the data segments and sends the total sum, where the receiver rechecks the result. Finally, CRC. CRC also stands for cyclic redundancy check, which is a more powerful method that uses mathematical division on binary data to detect even complex errors. So let's move on. So let's quickly compare. So what does it do is, like, parity is simple but not very strong. It detects only single bit errors. Checksum is stronger and is used in TCP and UDP protocols. So, and also the CRC is the most reliable and is used in Ethernet and Wi-Fi because it can detect burst errors effectively. These techniques ensure that even when millions of bits of data are transmitted per second, we can still detect when something goes wrong. Yeah. So let's move on to the next one. So we'll study about the random access protocol. So in here, like, now what happens when multiple devices share the same communication channel, like multiple user connected to Wi-Fi? This is where random access protocol come into play. The first method was Aloha, where any station could transmit whenever it wanted, but collisions were frequent, so it wasn't very efficient. Then came slotted Aloha, which basically divided time into slots, reducing collisions. The most popular one today is CSMA/ED, or it stands for Carrier Sense Multiple Access with Collision Detection, used in Ethernet. Here, each device listens to the channel before sending the data, and if a collision happens, they stop. wait for a random time and try again. Okay, so let's move on to the next one. This is like taking turns protocol. So let's go. Instead of letting like everyone talk at once, some systems make devices take turns. These are called taking turns protocol. So first one is polling, where a central controller asks each device one by one if it has data to send. Then the central controller grants permission and all. The second one is token passing, where a special frame called a token circulates in a ring. Only the device the token can transmit. And the third one is prevention of collision. This eliminates collisions completely and ensures fair access for all devices. So where we will understand DOCSIS. It also stands for Data over Cable Service Interface Specification. Uh, it is like one of the best real world uses of the link layer. So it's the technology that brings high speed internet to our homes through cable TV lines. DOCSIS devices divides the bandwidth into upstream and downstream channels and uses link layer to control to share this bandwidth efficiently among many users. This is what allows you and your neighbors to stream, download, and browse at the same time using the same cable network. Yeah, so this diagram shows that how the DOCSIS works, and we can move on. Yeah, so let's move on to the link virtualization and MPLS. The link layer has evolved to support virtualization and advanced routing techniques. So what link virtualization does is allows multiple virtual links to share a single physical connection, increasing efficiency and flexibility. MPLS, which stands for multi-protocol level switching, takes this further by adding short labels to packets instead of long IP addresses. Routers forward packets based on these labels, which makes routing much faster and supports quality of service for things like video call and streaming. You can see the diagram how data packets travel among many sources to routers. Yep. Let's go to the next one. So here we understand the like where we see the link layer in action, basically the application of link layer. So in Ethernet LANs, CSMA and CD ensures smooth wired communication. In Wi-Fi, a similar protocol CSMA slash EA to avoid collisions. And the third one is cable internet, which uses DOCSIS as we discussed earlier to provide shared access to homes. And so the last one is MPLS networks, which uses ISPs, like the ISPs and MPLS use manage traffic efficiently across their backbone network. So every time you stream a video or send an email, the link layer is silently working to keep your data safe and reliable. Okay, so let's summarize what we learned. The link layer basically provides reliable communication between directly connected devices. It performs error detection and correction using parity, checksum, and CRC. It manages medium access through protocols like Aloha, CSMD, and token passing. Technologies like DOCSIS and MPLS apply these principles to deliver real world internet connectivity. So, in short, we can say that the link layer is the backbone of reliable data transfer at the local level of networking. So, thank you for watching this presentation on the link layer. I hope this helped you understand how the layer ensures smooth, reliable, and efficient data transmission across networks. This topic is fundamental to understanding how the internet functions one layer at a time. So, thank you, and I hope you enjoyed.